All right, so first example question here we've got is two objects shown colliding head-on, velocity of a 9.5 kilogram object that's moving 8.4 meters per second to the left, and also you've got a 2.4 kilogram object moving 3.2 meters per second to the right. We're looking for the velocity of the object of the 2.4 kilogram object if the 9.5 is moving 5.4 meters per second afterwards. So this here is our before. Afterwards, we are looking for where this 2.4 is going, and the 9.5 is moving 5.4 meters per second to the left. All right, using law of conservation momentum, MAVA plus MVBB is equal to MA prime VA prime plus MB prime VB prime. All right, so plugging in the numbers here, we've got 2.4 kilograms traveling at positive 3.2 meters per second. The 9.5 kilogram object traveling at negative 8.4 meters per second is equal to the 2.4 kilogram object, and this is the velocity we're looking for, times the 9.5 kilo object traveling at negative 5.4 meters per second. We're going to simplify this, starting with the sides. 2.4 multiplied by 3.2 gets us 7.68. Adding to that 9.5 times negative 8.4 gets us negative 72.12. 9.5 times negative 5.4. So you got 2.4 V plus negative 51.3. Simplifying 72.12 and negative 72.12, we're going to subtract from that negative 51.3. So negative 20.82 is equal to 2.4 V, and dividing both sides by 2.4 will get you a final velocity of negative 8.67 meters per second. That negative is indicating to the left, therefore answer correct here is B. What happened? Second question here, the numeric response. We've got 1,575 kilogram car traveling at 10 meters per second, colliding with the stationary, and they're combining. The bumpers are coming together, and so we've got that combination, MAVA plus MVB is equal to combined mass and the combined velocity. So 1,575 multiplied by 10, and we're going to just assume it's to the right, positive 10 here. With the stationary, so we're just going to bypass the mass and velocity and call that a momentum of 0. Total mass of the two vehicles afterwards, we're just adding those two masses of 200 and 2,250 and adding to that 1,575 for a total of 3,825 VAB. And so afterwards, you're now just combining. You're going to be taking 15,750 kilogram meters per second of momentum, and going to be dividing it by the combined mass to get the velocity of the objects afterwards. And so when you run this calculation, you should wind up with a 4.11 meters per second is equal to VAB. And so after impact, 4.11 as being your answer. Okay, next question. We've got inelastic collision. Energy appears to be missing. That's kinetic energy, and it is being converted. That will always be usually within the form of sound and heat. So answer here is C.